For our last example, what we're going to do is we're going to actually graph some real world data. What? You mean we can actually use some of this math in real world? Yeah, I know, it's weird. That's why it's called analyzing your polynomial functions, your graphs, because you're going to be seeing what they actually show you. So down here, for example 4, it says the weight, W, in pounds of the patient during a 7-week illness is modeled by the function W of n equals 0.1 n cubed minus 0.6 n squared plus 110, where n is your number of weeks since the patient became ill. So where in the world do our x's and y's go? Well, these n's are in the place where our x's usually are. So that means this side of our t-table is going to be an n. This w then represents your y. So we're going to say w over here, or w of n. So when we choose our values to plug in, what we actually need to do is we need to type in this equation. And so let's go to our calculator, go to y equals, clear this out. We're going to put a 0.1. Now instead of putting an n, what we're going to do is just put an x, because your graph will recognize an x to the third. Doesn't matter, I would use an x here. Minus 0.6 into the, or x, sorry, x to the second, plus 110. So we go to our graph. Here's our graph. Where did our graph go? Oh my goodness gracious. Well, this one goes from 0 to 10. If you look at your equation, here, this 110, isn't this your y-intercept? So you got to keep that in mind anytime you're talking about your graphs when you're trying to find something on your calculator. So what we can do is we can change our function. We don't care about these negative weeks. That doesn't make sense to go back weeks. So let's change our window because it's asking for us to find the a 7-week period. So we're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to make this window right here as much as possible. We will have a break right there. So let's go to our window button, which is right next to your y equals. And we're going to change your x minimum. This is how far your graph goes to the left. Notice this says negative 10. It's going negative 10 here. We're going to change that to a 0. Actually, I'm going to make that negative 1. I like to see that. Here we go. So negative 1. Go down. Now x max, I'm going to make that a 9 according to my function that we have, or the graph that's given to us. Hit enter. And then we're going to go to our graph. So you see this changed our viewing window. Go from negative 1 to 9. We're still from negative 10 to 10. So what we're going to do is we're going to hit this zoom button in the middle. Hit zoom. And then if you go down to 0, it's called a zoom fit. Zoom fit, which is 0. Let's see what this does. So hit 0. See if there's a graph or function. Oh, hey, there it goes in, down, and then back up. Woo! That's a good time. Well, what we're going to do is we're just going to graph from here up. This, remember if your y-intercept is a 110, this is probably a 107, 109, 108, 107. The best way to double check that is to go back and look at your window. So notice how our window, our x-min and our x-max is still the same, but what it did, by using your zoom fit, it zoomed in on your important part of your graph. It goes from 106.8 up to 134. So let's actually make this a y-min a 106. And then we're going to have our y-max is going to be a 135. We're just going to make it a little bit prettier. And then we go back to our graph. So here are our values. This is what your graph should look like. So if you go to your table, second table, remember we don't need any of these negative values because these are negative weeks. So what we really want to do is we want to start at week 0. So if you just cursor down, week 0, and we're going to plug these values in. So for 0 on your table over here, 0 week, your first week, your second week, third week, fourth, 5th, 6th, and 7th. we need to plug in our values. So for 0, we're going to have 110. For 1, you're going to have 109.5. For 2, you get a 108.4. For 3, you get 107.3. 4 is a 106.8. 5 is a 107.5. Notice how your values are going back up. 6 is a 110, and 7 is a 114. So what we can do on our, let's label our axes. So along your x-axis, these are n. This is your number of weeks. Okay, that's what n represents, number of weeks. This is your W of n, so that would be your your weight. Whoops. So that's not very good. Sideways W. So if we do a sideways W here, go back to here. This would be the weight. And what we should do is we should label your y-axis similar to whatever these start at. Well, the lowest you go is a 106.8. So we're going to make this a 106 right here. Whoops, dang it. Change colors. Pink. So this will be 106, 107, 108, 109, 110, 111, 112, 113, 114. So now let's just go ahead and plot all of your points. So you plot all your points, start here, over 1 up 109.5, you're right here, over 2 up 108.4, so you're going to be around here, over 3 up 107.3, so that's going to be right about here, and then over 4 106.8, that's going to be here, that's the lowest we go. Then you go back up to 107.5, then you go back up to 110, and then you notice it starts increasing a little more rapidly. So here is what happens with the weight. Now it should make a little bit of sense, because if somebody is sick, a lot of times they don't eat as much and they're not going to be gaining weight, they lose weight. So here's your graph. So what we need to do is we need to figure out what happens, or describe your turning points. So for B, it says describe your turn points. Well, according to our graph, we only have one turning point. This is your lowest value right here. So what we need to describe in terms of this problem is the relative minimum shows the lowest weight is 106.8. Let's see, is that pounds? It's 106.8. I think it's pounds. Let's check. Double check, double check, double check, double check. Yeah, pounds at week 4. So that's what our turning point shows here. Now we don't have a relative max because the graph keeps going up. What trends does the patient's weight does the graph suggest? Well, obviously, the patient lost weight for the first 4 weeks. Must have started feeling better after that, because then they started gaining weight. The patient's weight declined for the first 4 weeks, and then increased after that. Now eventually that graph is not going to keep going up, and it'll start to taper off, because your weight's not just going to continue going up. So that is how you can actually analyze a real world graph, and hopefully that helps you with what you may do, because all you would be doctors, and you'll have to read these graphs and read these patients' weights and everything. So hopefully this example helped out a little bit, and just keep in mind, this is how we graph. Analyzing graphs, polynomial